So we talked about molarity, and here's another term called molality. They sound very familiar. However, they're a little bit different. Yeah, the way we calculate it is very similar too. Reason why we have a different term for concentration of the solution is that we most of the time we use molarity. However, when we want to know the concentration of a solute present in situation where there are temperature changes, molarity won't work because when there's temperature increase, if you dissolve something in the solvent like water, when you're boiling the water evaporates. So the number or the volume of solution will change, right? So, in order to make accurate data observation, another term we use is molality. It's also a concentration of solution, but molality is a solution represent the moles of solute divided by kilogram of solvent. So earlier molarity, we talk about liter, which is in volume, but here and also in solution. But here we talk about the kilogram of the solvent. Okay, and then this is our formula. Make sure you write this down too. The way of calculate molality is the same as calculate molarity, just different formula. Make sure you know that here molality is kilogram of solvent, and then molarity is mole of solute over liter of solution. So when do we use molality? We use molality to express the concentration of the solute when there's relate to vapor pressure and the temperature change. We're going to talk more about the solution, its behavior and property under the changing vapor pressure and temperature after spring break. Well, the reason why molality is used is because its value does not change with change in temperature. So we can have a more accurate reading. And please watch this video, the difference between the molarity and molality, to have a clearer sense of the difference of these two concepts. You can watch it here, or you can watch on the video I post in Google Classroom. How do we calculate it? It's the same thing. Okay, let's look at a sample problem. Determine the molality of a solution prepared by dissolving 28.6 grams of glucose into 250 grams of water. So, we have to write our known given, right? Our mass is 28.6 grams. And our solvent volume, it's a mass of solvent this is mass of solute is equal to 250 grams of water, H2O. All right. Once we have given, we have to write our formula. Our formula is Molality, small m, equal to mole of solute over kilogram of water. So small m, molality, is mole of solute excuse me, over kilogram of solvent. Do we have mole of solute? No, we don't. We have mass. So we have to convert the gram of solute into mole. Do we have kilogram of solvent? No, we have gram. Okay, so that means we also need to convert this into kilogram. So convert 28.6 glucose into mole, so it's 1 mole. Okay, is how many grams of glucose? You have to use a periodic table to find it. All right, it's roughly 180 gram, and then you get, well, here's the answer, 0.1587 moles of glucose. And then how you convert gram to kilogram? 250 gram then convert to kilogram. 1 kilogram is equal to 1,000 gram, right? Multiply top, divide by the bottom, 250 divided by 1,000, you get 0.25 kilogram. Okay, now all you have to do is plug in number. This number become the mole of solute. This number is the kilogram of solvent. And then voila, you get your answer, 0.635. All right, there are several examples of how to calculate molarity, and molality. Like I said, in molarity, you can do everything conversion in one step, or you can do conversion in several different steps. If you want to break it down, do the way I do. If you want to put them together in one conversion table, I'm fine with it too. Make sure you have the correct unit, okay? So please do the homework, the worksheet for molality. And then we are going to talk more about these in next lecture. And remember that our meeting on Zoom is on Thursday, okay? I'll see you later.